In the previous video, we talked about what happens when we have a function. We looked at the square root of x, and we said it has that left endpoint at 0, and we really wanted to be able to speak about the continuity of that function across its domain. And so how do we reconcile this issue with the fact that there's nothing going on out to the left of 0? Well, we can say that a function is continuous. And today we're going to speak about intervals where a function is continuous, not just at a particular point. But a function is continuous on the interval, the closed interval a, b. A function is continuous on that closed interval a, b, if and only if, first of all, it has to be continuous on the open interval a, b. And if you think back to that square root function, we don't have any kind of break in continuity on the open interval from 0 to infinity. The only thing that we were really kind of hung up on is what happened at the endpoint. We wanted to be able to close that off at 0. And so we add in this following statement here. So if the function is continuous on the open interval a to b, and if the limit as x approaches a from above of f of x is equal to f of a, and if we have a closed off end here at b, the limit as x approaches b from below of f of x is equal to f of b. And it's important here we note a is the left endpoint. So we want to approach it from the right because there is no approaching it from further left. So if we approach a, the left endpoint, from the right, and it equals the function value at a, we're okay with continuity. If it approaches b, which is the rightmost endpoint, so there's nothing to the right of b, if the limit as x approaches b from the left is equal to f of b, you're okay with that rightmost endpoint. So we go back to that question from the previous video. Is f of x equal to the square root of x continuous on the interval from 0 to infinity with 0 closed off there? And the answer is yes, because we can definitely say, and we can just kind of apply our intuition from the graph, we can say it is continuous on the open interval 0 to infinity. And then when we address what's happening at x equals 0, which is the leftmost endpoint, we know that f of 0 is equal to the square root of 0, which is 0. So the square root of 0 exists, and so f of 0 exists. And for that left endpoint of my domain, I want to look at the limit as x approaches 0 from the right of f of x. And you can either do this from the graph that we did of the square root of x, or you can evaluate it directly, but it is in fact equal to 0. And so this condition right here is met. Since f of 0 is equal to 0, which is equal to the limit as x approaches 0 from above of f of x, then because we have this statement right here, we can go ahead and close off this interval and say that f of x is continuous on the interval where we get to close off 0 and then head to infinity. So this idea here that when we look at the endpoints of a domain, that we really only have to look at it from the one side where it's approaching that endpoint is what allows us to go ahead and close off that particular interval.